Hey guys, my name is Austin from awfulmedia.com, and this is part one of a new series in the Unity 3D stuff that we're going to be doing. Now in this part we're going to be creating a very simple game. It's a pretty cool game, I'm not going to lie. When I was creating the quick prototype, I thought it was going to be a kind of a silly little stupid game, and it is silly, but kind of turned out to be something like, maybe I will turn this into an actual game. But then I thought, nah, I'll just teach people how to do it, and maybe they can do that, and send me a copy of it. That'd be cool. First of all, though, we had a poll that decided that the game that we're going to create with the information that we gained from the Introduction to C# series was going to be a side-scrolling platformer. And that is still true. But before we do that, I wanted to create a even simpler game. Something not even that difficult. And I know I'm downplaying the side-scrolling platformer, but they're not simple games. You know, they can become very complex. If you want to make them really good, really tight, feel really good, have really good level design is the most important part. You have to put in a lot of work. It is a difficult thing. But our platformer is going to be rather simple, something you can build on if you want to in the future. But before we even get into that, we're going to be creating a very simple game that is pretty fun. You control this blue cube. You have to get this blue cube to this green cube. That sounds easy enough, but you have this red guy here. That's going to be patrolling a path. He's going to be walking from point A to point B to point C, back to point A, or D, or however far you're going to go with it. It's unlimited length you can go. It's based on something that we've talked about in the past, and we'll go over that. Pretty cool. It's pretty fun. And you make your way around, go to the green cube, it goes to the next level. We'll have some kind of scoring system or something. Again, this is just a prototype. This is not final. So when we start building our own version, it may turn out completely different. Who knows? I will go ahead and play this and talk about it as I play it. Now, the controls are very slippery. I just float around this world like I'm on ice. But that was kind of intentional. The main thing was I wanted it to be challenging, but very simple. So if you just touched the button and went where you were supposed to go, well, I mean, you go the direction that you're supposed to go in still, but I just fell off the map. But if it was just, slide until you let go and then stop sliding, there would not be much of a challenge. But now you have to kind of control yourself a bit more. You have to keep yourself in control, because you can start spinning out pretty quickly. Like that, and then I got stuck on the side of the world. But what we have to do is dodge this red guy and not run into him. Oh, and he exploded in the particles. I guess you saw that. But I'm going to make my way in there. Touch that, and it goes to the next level. Now, this level is a bit messed up at the moment because these walls are made up of individual cubes. That was just for quick prototyping. We'll do solid objects all the way down, all the way through here, all the way through there. Because now, with these single cubes, I have a bunch of box colliders. And you can tell that when I'm trying to scoot my way down this hallway, I'll be getting stuck and stuff, and it's really annoying. Especially in a game where that's not good. Right there, you see me hit that corner. And I just hit something that I don't think was there, maybe? But, I don't know. Maybe it was. Maybe I wasn't paying attention. And I'm going to scoot out here, go down here. Don't want to touch that guy. Scoot in this little cubby hole here. Wait till that guy passes. And then run into him as fast as possible. Now, the goal is to get to the green thing. I don't have to do this to prove my point, but I will. I want to just fly by him and then go to the green thing. Nothing happens, though. There's no more levels. Didn't want to waste time designing levels, but that's how that works. See, no level 2 found. So let me show you what makes up this simple game. I have 4 classes. We'll probably have 5 because we'll have a game manager class. That's not something that I wanted to create for the prototype, but it is something that we will use for our game. Something to keep score, something to continue levels and control menus and stuff like that. Something that just controls all of that stuff in a single class. That'd be good for us, I believe. But for now, we have a destroy class, a patrol class. Well, the destroy class takes care of destroying objects. Whatever object it's placed on, you can set a lifetime. And then after that time is up, it will destroy the object. The patrol class handles the patrolling of the enemies. It cycles through the patrol points you set throughout the world and goes from A to B to C and then loops back around to A. Now the player class handles some of the game manager stuff for now and collisions and stuff whenever we hit the enemy or fall off the map, stuff like that. And player movement handles the player movement. Pretty simple. I said we would be using the character controller, but I decided that maybe we should start with something a bit, I don't know, a bit more low end when it comes to that kind of stuff. It's just a physics object in Unity. It's a rigid body, and we have a box collider attached to this guy. And that's all we have. We're applying forces to the rigid body based on our input, and that's that. So I'm going to go ahead and save this first of all. I'm going to make a new project, and I'm going to call this, I don't know. First of all, let's go to my Google Drive. What do I want to call this game? Let's call it Go Home. Okay, select that folder. It's going to be 3D. We do not want any packages, and we'll click create. Probably notice my editor is pretty crazy. This is how I like to work in it though. So, yeah, it may not look like it's very efficient for working, but I like it. It's fine for me. We're going to create a folder to start with. I want to go new folder. I want to call this one scripts. Let's make another folder. This one will contain objects. Make another folder. This one will contain materials, like textures and stuff like that. We won't have any textures. We'll just have some basic Unity materials, but for now that'll work. Materials. Let's do one for levels, so we can keep our levels in. That's all we need. And inside of our scripts, actually let's create the world first. I want to go create game object, go to create other, and I'm going to create a cube. I'm going to center this cube in the world. And then I'm going to scale, this is going to be my floor. So I'm going to scale this cube 0.5 on the Y, flatten it out a bit, and make it 10. We'll do 20. I don't have it set up where I can use a mouse and keyboard at the same time. It's kind of difficult. But notice that the grid is going through our cube. That means that 0, 0, 0 will be inside of our floor. So I want to lower this -0.5 because the anchor point is in the center of the object, and I want to make sure that the top of the floor, the surface of the floor, is at the 0 on the Y. So objects will be placed on top of the floor. That's the idea, at least. I want to take my camera, first of all, and let's raise it up a bit. Rotate it down. Let's go up a bit more. Okay, I want to create another game object. Let's go ahead and call this one floor. I'm going to call this one the player. I want to zero this guy out. There he is. Now his 0 is actually going to be inside of it as well because his anchor point is also in the center of the object. So we're going to raise this one up 0.25. That math should make sense, I hope. So now we have our player cube on the floor. Let's add a light to the scene so we can actually see what's going on. I want to create a directional light. Now this is where it gets kind of fun because I want to make this one a bit orange. And we're going to do a fill light. Let's do a bit orange. Lower the intensity just a bit. And I want to go here and hit Control D. Make another one of those. But this one I'm going to flip around the other direction. I can't tell which way that... Hold on. Which way is that light? Let's bring these up. It doesn't matter where in the world these directional lights are, as they always shine. It's like a sun, right? It's going to always be there. They light up everything, so it doesn't matter where in the world they are. It's just based on the direction they're facing. So that one is facing. We'll do a rotation on the X of that. Now, if I was to make this one a blue color, something like that, and drop that intensity quite a bit, and just get that blue color there. Now, this is a something that you'll want to do, and just keep messing around with it. Now, I'm going to go to project settings, and no, not project settings. I'm going to go to render settings, and over here we have an ambient light. This is something you'll notice that does quite... It is just the ambient light. There's no other way to explain what it does, really. But if you're working with your shadows and stuff, you're like, I don't know how to make my shadows different colors and stuff. Just fiddle around with all these different settings, and you'll figure out how you'll get what you're looking for. I want to turn on shadows for my orange light. Do hard shadows because they can do real time in Unity Free. The soft shadows do not do real time in Unity Free. It is a pro feature only. The bias looks okay. Notice what the bias does here. It's important to note that. Go too far down, you'll see these squiggly lines. Technical speak, I know. All right, so we'll just put it up to 0.04 for whatever reason. Now, I want to let's bring our cube down towards the camera. Oop, not that cube. Let's bring the main cube, or the player cube, down towards the camera. Where's that? There. And now I'm noticing that I'm a bit blown out with the color. So I'm going to go to render settings, and we're going to give this a deep orange. Something like that. And I want to mess with the lighting a bit, as this lighting is not quite where I want it. Okay, so what I want to do now is I'm going to create a few materials just to get this all together and see how we can make this look here. In the materials folder, I'm going to create a material. Now, Material in Unity has many different shaders built in that we can use, but you can also write your own shaders if you are into that kind of stuff, or if you're any good at that kind of stuff. So we're going to just create a simple diffuse shader. We're going to, or not create a diffuse shader, use a simple diffuse shader, and just apply a color to it. Now, our players are going to be that same blue color that I used in that last one. Just a interesting blue color. Now, how do I apply this color? First, I want to name it. Name it player. This material is for the player. Watch this. I can just drag this and drop it on the player. That color sucks. I'm never going to be able to make that same look that I had before. I just knew I wouldn't be able to. We'll figure it out. Anyway, I'll make a new material. We can just duplicate these materials. Just highlight it and hit Control D. Oh, my voice went out. Make a ground material. This one will be a green color. Something like that. I'm going to drop that on the ground. And then I'm going to create a material for the enemy. It's going to be a red. And then let's make one for the walls. A beige of some kind. And that is the materials that we're going to be needing, at least for now. You might make some more in the future. So we have our player. Now, how do I make our player move about in the world? That's a good question. We have a player cube here, and he has a box collider. That is this green thing around him that will help him detect collisions. It's a hitbox, in a sense, right? If you're used to that terminology. And we can use that to collide with objects and to detect collisions. But we also need one more physical component that's going to help us maneuver our player about, moving around using some kind of physical force. And that is a rigid body. So I'm going to go add component, and you can search for the component here in the search bar. Or if you don't want to do that, and we're on this page, I would go to physics, and I would go to rigid body. You can also add a component by going to component and then do physics, rigid body. Clicking on that will do the same thing. So we have a rigid body here now. Now you can affect some of the different physical properties as you can read here. And a lot of these are pretty good about where they're at. The drag we'll be messing with to get it to feel how we want it to feel. The constraints, we don't want this object to be able to rotate, but for the fun of it, for now, we'll allow him to rotate, just so we can play around with that. We want him to use gravity. We want all this to stay the same for now. We'll mess with some of it later on, but for now, that's good. Now, watch what doing that does to this cube. I'm going to drag him to the center here, and I'm going to click play. Look at that. Right off the bat, we have physics applied to this object. Now, what if there was no rigid body? I'll just remove this rigid body, click play, nothing happens, as it is not being affected by the physics in this game world. Now, if I was to turn off this box collider, add a rigid body, what happens then? Whoop, didn't collide with the floor, he kept on going. He would go literally forever, so that's not good. We'll turn back on our box collider, and we'll leave the settings here the same. Now let's actually make it where we can control this player with player input. Now I'm going to go to edit, go to project settings, and go to input. Now these are all of the predefined or default input fields that we could use, but that's a lot of stuff that we don't need. So I'm going to hit 3. Horizontal, vertical, and fire 1. We probably won't use that, but to keep an extra one there. We can add as many as we want to and create our own. I can edit all these settings, the name, and you can add a description for the name or descriptive name, such as what it actually does. You have the positive button and then the negative button, or sorry, the positive button and the negative button. Let me get this right here. The negative button and the positive button, okay? Then you have the alternatives. So you have W, A, S, and D, and then you have the arrow keys. That would be the alternative. So you can have two things that do the same thing. That's pretty handy. Now this built-in input manager is pretty cool. You can use this in the future if you want to create an options menu and then set up a system for people to put in their own key bindings. This would be helpful for that quite a bit. We're going to be focusing on this horizontal and this vertical. Now these are axes in a way. Well, they are axes. What happens is when you are controlling input with, say, an analog stick, you notice in a game, if you were to turn the analog stick to the right, turn it all the way, the character would rotate all the way at the highest speed possible. Turn it halfway, he would rotate at half speed. So you have this progression from 0 to a number, right? Because you're going from 0, which is standstill, to the rotation speed. Well, how do you get to that rotation speed with progression? Well, you multiply it by a modifier based on the input. So we can use these axes here and go from 0 to 1 based on the degree of input. So if you have a half input, it would be 0.5. If you have a quarter input, it'd be 0.25, and so on and so on, and everywhere in between from 0 to 1, and then the opposite direction, 0 to -1. So up would be 0 to 1, down would be -1, right? So that's pretty much that. And that works for all 4 ways. That's how you get that progression when you turn the analog stick. And we're going to be using that in our game. So we're going to be detecting the input, storing it in a variable, and then doing something with it. Sounds like a lot of crap, though. How do we do that? I'm going to go to my scripts folder. I'm going to spit on my monitor first, and then I'm going to click C# script. And I'm going to call this player movement. Now I'm going to double click on that and open it up so we can start writing our player movement script. First off, I want to set a couple variables. The first one is I want to set a variable that we can edit in the inspector where we can modify the speed modifier for the player. So this will be a public. We'll make this a float. A float, remember, is something that you can have decimal points instead of whole numbers. That's the point of a float, but it is a bit more technical than that, I guess. But for now, that's how we'll describe that. I want to call this move speed. Now I want to grab the input and store it in a variable. Now the variable that I want to store it in will be a vector3. A vector3 is an XYZ coordinate. So you have an X, you have a Y, and you have a Z. So this one variable will store 3 numbers. And this will relate to a position in a world. So you have, your X, Y, and Z coordinate would be a point in a world. It'd be a vector in a world. And then we're going to use that vector to control our player movement. So I'm going to do public. Not be public. We'll do a private. Vector3. Notice there's a 2, 3, and 4. But vector3. And I will call it input. And for now, that's what we'll work with. So in our update function, which is called once per frame, as it states here. But remember, once per frame, that means if I have 600 frames per second, this will be called 600 times a second. If I have 60 frames per second, it'll be called 60 times a second. So you have to take that into account when you are working with things that are moving, or if you're controlling speed, which we are, and we will go over that. So let's do an input is equal to, so we're going to be setting the vector3 input equal to a new vector3, and a vector3 be an object in this way, as we are working in an object-oriented programming environment. Remember, objects are things that we can create instances of and use them without actually having to use them. We just use an instance or a version of them. So we're going to be creating a new vector3 and setting it equal to the input vector3. So new vector3. Now inside of this, I want to set an X, a Y, and a Z. Now the X I want to set will be the horizontal input. So the horizontal axis, set that to equal the input dot X. So I will set it up to be input dot get axis, which is going to return the value for the axis that we put in string here. And the string value will be horizontal, as that is the name of the input. So input dot get axis horizontal. Now this could be dot get button, and then you could pass it a string value for the button. It could be dot get key, and then you could pass it the key code. There's a lot of different ways to go about doing this, but horizontal and vertical are the axes that we're going to be working with. Now on the Y, we're going to pass 0, as there's not going to be any vertical movement. We're not going to be jumping. We're not going to be falling, at least controlled by our input vector. It'll be controlled by physics. So nothing passed to the Y. Now the Z will get the vertical axis input information. So input.get axis, and we're going to pass it the vertical string value. And that's that. Now if we were to print out input, so let's print input. Over here in my console, you'll see what my, let me not maximize it on play. What's that? There it is. Oh, I got to attach, let me attach the class first. That's important. Let's attach the class to the player. I think I missed. No, it's there. Click play. Go to our console, and you see all the print statements being printed here. Now, if I hit to the right, scroll to the top. If I hit to the right, you will see the X going up to 1. Let go, it'll progress back down to 0. Hit to the left, it'll progress to -1, and then up, same thing, but on the Z, and down, same thing, but also on the Z. So that's how input works. Now we can take that information, pass it through to a force method that will apply force to a rigid body, and then multiply that by our speed modifier, which we set right here in the move speed variable. So it'll always be from 0 to 1. So I multiply that by my speed. The speed will be between 0 and, say, 20. So 20 times 1 would be 20. 20 times 0.5 would be 10. That's the idea. So you have 0 to halfway mark, then it'd be going at 10 speed, which is half speed. That's how the progressive movement works. Now let's go ahead and make our player move. So I want to grab the rigid body. Now notice I don't need an object reference because I am on the same object. And I also don't need a component reference, as the component reference for the rigid body is built into Unity. I'm guessing in the compilation, when it compiles it, it'll actually set up the reference for me. Maybe it just doesn't need it, and it's, I don't know. I'm not sure what the behind the scenes thing is, but we don't have to grab the component ourselves as it is set up for us. So I'll just do the rigid body. Then I will do .add force. Now add force is going to add a force to this object in the vector 3 that we give it. Think of adding force like pushing. So if I add force along the X and the positives, it's going to push the object on the X-axis to the right, depending on your coordinates, however that would be. I'm just saying stuff now. But I will add the parentheses. Then I will pass an input vector, because now we have our input stored in the vector 3. We know what the X and the Z is, and the Y is always going to be 0. So the add force should be in the direction that the players want to move with the arrow keys, or the W, A, S, and D. The way the input is what it's based on. So I'm going to pass that into the add force method. But this isn't going to be enough to move, because now we're going to be moving at 1 speed. We're going to be moving that. Let me show you here. If I click play, get to the left, nothing happens, right? But what's happening here? If we actually look at our coordinates, our rotation is kind of being crazy because we did not freeze the rotation. If I hit to the left, though, you'll see my coordinates are changing. They're just not changing as they should be. So what I want to do then is I want to actually multiply the input value, which we talked about already, by our move speed. Hit Control S. Now what happens? It should just work, right? That should be it. Turn that off. I don't. Okay. Well, that's kind of fun with the tumbling thing. And we just and then just go on. So what I wanted to do is actually freeze the rotation. So it cannot rotate on any axis now. Move to the right. Either way, we have movement now. As you can see, I'm moving around this world. But you notice that slow progression? That's not what I want. I want it to be slidey, but I don't want it to take forever to get to that speed. So what we can do is we can set up a system that will check to see what our speed is. If the speed is below a certain point, it will add speed to it until it gets to that point. Because right now, it's just going to do this forever. In the update function, we're going to be adding this add force just over and over and over and over every single frame. So what we should do, I should do a private, we'll do a float and do a max speed or something like that. And then in the update, I'll say if, not dictionary, if we have to get the speed the object is currently moving in, but we need it in a number that we can read and compare with a float. So if we were to get the velocity of the object, that would be in a vector 3. But we need just the single speed. I don't care what direction it's moving in. I just want a speed and a single number. So say it's going 20 units a frame. I don't care about the X, the Y, the Z. I just need the single number. To do that, we'll do rigid body. Again, no reference. Dot velocity. So that'll give me, as you see here, the vector 3. I don't want the vector 3. I want a single number. So we can do dot magnitude. And that'll give me a float. And I can say if that is less than the max speed. So we're going to say if we're going slower than I said we could go, which will be, what do you think? 5 just for testing? Add an F there, as that is a float. You have to add an F to process a float correctly. If not, you will throw a compiler error. Now, if that is true, I want to continue to add speed. When that becomes false, I don't want to add any more speed. You're going fast enough. So stop doing that. And then every time that becomes true again, it'll keep adding speed. That's the input though. That's not what I want to put in there. I want to put the actual add force in there. Just like that. Now we hit Control S, go back in here, and see if that works for us. So I'll click play, follow the ground, hit right. As you can see, I'm moving at 5. Let's up our max speed, or move speed on our max speed, and I'll move to the right. And now notice I get to the speed a bit quicker, and I get to 5, and I stop. My move speed is more than 5 though. Well, that's because we have that damp movement starting out that I would like to add a lot more speed at the start. That way it's a bit snappier. So if I was to up this to like 50, for instance, and I go to the right, see that it's a bit snappier. Now one thing we could do is, since we're getting the axis like we are, and it's going the 0 to 1 thing, we could get the axis raw, which would just be 0 or 1. So if we don't care about the progression, we could just say, hey, snap to it just like that. Don't do that that progression thing. And now it'll just be a bit snappier. So when I touch it, it'll just go that way when I touch it. That's a pretty cool movement. For some reason, my Z is changing when I move my X. I bet that has something to do with gravity. What could that be? Is it gravity? Let's turn gravity off. See if my Z still changes. No, so my Z don't change now. I can't move back to the right for some reason though. My gravity turned off. Huh. Because I'm not on the ground anymore, it just like keeps going forever. Let's add some drag to this. And now it stops itself. And my Z does not change without gravity. Turn gravity on, and now move to the right and left. My Z changes. What is that? Why is that? The ground's not rotated. Is that a scaling issue? What? Well, that's interesting. I didn't, I am slowly moving up on the Z. Not that big of a deal, really, but we can't have gravity without that weird little bug. Gravity's on. Let's modify the gravity value. I'll go to physics. The gravity value is what it should be, but if I was to bump this, let's bump this up pretty significantly. Notice I'm a bit heavier now, as that's how gravity works. If I select this again, yeah, my Z's definitely changing more now. We might just have to live with that weird movement, as that is not something, wrong place, that I expected to encounter. So we can have gravity. I mean, this little game, you could change out the rigid body if you actually wanted to make this into an actual game with a character controller. But I just wanted to go over, what am I doing? Let's go back to like, out there. I just wanted to go over the rigid bodies and how you can control them. I thought this would be a good way to do that. We have a weird thing. Well, whatever. It's not that big of a deal, honestly. I notice how we're moving like that. I don't know. But anyway, for now, that is our character movement. But one thing you notice, let me bring myself closer to the floor. Goodness. Now, in the game that you saw me playing, the movement was a bit slippier. That's not a. It was a bit. It was a bit more slidey. I don't know what the word I'm looking for is, but it was a bit different than this. Let's try to recreate that. One thing I had, if I was to go into, say, materials, I want to create a new physic material. I'm going to call this no grip. Not sure what I call the other one, but we'll call this one no grip. Now, what a physic material is something you can attach to physical objects, something that has a box collider, and you can control the friction and the bounciness, which is what we want to work with. I want to add a bit of bounciness to what I apply this to, because you saw me bouncing around before. Not a lot of bounciness, just a bit. And the friction's kind of already correct, so I'm going to drop that on there. Oops, did all that in play mode. Drop that on there now. I don't know if that actually... Let's turn the frictions down a bit. Yeah, it's a bit slidier there. Slidier? I'm just making up words to explain this. What we could also do to affect that, the way that changes, is if I was to go to my player, I could lower the drag a bit, making my stop a bit slower, as I would slowly come to a halt instead of so sudden, to give us that floaty thing that we have that I can't describe with words, apparently.